Hello, am I audible? Okay, all right. Okay. Uh, so I don't know what you did, but I'm assuming that you did this. So let us take this and keep a root here, and then create a separate script tag. So script type equal to text slash double. Things. Yeah, dot component. Right? Okay. And then we need the reducer. So I'll take the reducer, copy the reducer, and the code for creating the store. So I'm taking all of them and then paste it here, right? And then paste it here. Okay. So we have created the store, we have the component, we have the reducer. Now we need to keep all of them together, right? So we need to connect all of them together. So how do we connect all of them together? Um, So first and foremost, there should be a way by which the component can access the state from the store, right? So here, let us write a function. So function render app, and I will render react dom dot render spinner pass the reference of the store. Store equal to the store as the props. Okay, comma. Okay, and then make sure you call render app, and then store.subscribe of the render app. Okay, very good. And in the component, we will take the data from the store, right? From the props. We'll take the store from the props and we will display. So constant value equal to this dot props dot store dot get state and display the value here. And when the buttons are clicked, right, we just need to call dispatch the respective action. So let us write on down click is equal to a method, do something, and then on up click is a method and do something. What is that we want to do, right? Let us create the action. So constant down, down action is equal to an object with the type attribute and the action name is down. And then what do you want to do? This dot tops dot store dot dispatch of the down action. Now similarly, let's come here. Constant up action is equal to an object with type is up, and we will simply dispatch this. So this dot tops dot store dot dispatch of the up action. Yeah, that's all, right? Let me add reference to the script libraries. So script colon source, how many, right? So React dot development dot JS, React hyphen DOM dot development dot JS, then this will be double dot and dot JS. And copy those script files. Okay, now load the page in the browser. What is missing? In graph, we have com.render, document.getting the ID of book, and return this. We need to add the on click. So on click is equal to this dot on click, and this is on click is equal to this dot on. Okay, so now it is rendered. Now it is rendered. You call up, up, up. It is updating. You call down, down, down. It is working just fine. Make sense? So this is just the state management logic. And what I have done, I have created the UI for that particular state management infrastructure. Okay, I'm checking in the code. Take this, have a look at it. Code is checked in. Please check the code, go through it. I'll be back in a couple of minutes. All right. Any questions? No. Okay. So all we are doing is we are creating the spinner component, and from the component we are dispatching the actions, and then we display. We take the state and we display to the user, and then we keep doing it. We re-render the whole component every time the store says that the state is changed. Right? Very good. Now, if you look at here, right, the component has knowledge about the store. The component has knowledge about the store. Should the component know about the store? Right? Should the component know about the store? So we can say no, the component need not know about the store. And what are the reasons why the component depends on the store? There are only two reasons why the component depends on the store. One is to extract the state, and the other one is to dispatch the action, right? So we can remove the dependency of the store and pass only the data that the component needs from the store. Okay, so let me write this. As a matter of fact, I will keep writing it here. So what is this? This is the initial implementation. This is the initial implementation. And the second one is going to be remove the dependency of the store. Remove the dependency on the store from the component, right? So how are we going to do that? Very simple. We will take the value from the store. So constant value is equal to store dot get state. That will give us the value. Pass only the value, right? Value equal to the value. Pass only the value. So here I will directly get the value from the props and display. I don't have access to the store, right? I will directly get the value from the props and I will display it. And then what else? The other reason why the component depends on the store is to dispatch the action, right? So we will pass the reference of dispatch. So dispatch equal to dispatch. Store dot dispatch. Sorry, yeah, dispatch equal to store dot dispatch. I am passing the reference of store dot dispatch, and so here we will simply create. Call the store dot dispatch directly. So this dot props dot dispatch. This dot props dot dispatch up action, down action, etc. And this we should automatically render. So let me save this. Go to the browser. This is 02 index.html, right? And go here, up, down, working just fine. Okay, so all we did is remove the dependency on the store from the component, and we pass exactly what is needed. One is it needs the data, the other one is it needs the access to dispatch. Other than that, it doesn't need the whole store as it is. Okay, the reason is the component now is more intelligent. The component knows a lot of things, right? And yesterday morning we discussed that component should not be an intelligent component. Component should be dumb, right? We learned that to build the simple secret for building manageable, maintainable UI is that your UI should be dumb. It should do only two things. It should react to user actions, it should react to model changes, and it should present the data, right? So it should not do anything else. So we are going to slowly remove a lot of knowledge from the component in an attempt to make it dump, and I'm going to do it in a step-by-step fashion. So first step is remove the dependency of the store from the component and pass only what is needed. What are they? One is the data, the other one is access to dispatch. Right? So I'm checking in this. Take this, have a look at it, and let me know if you have any questions. Code is checking. Are we good? Okay. Now let me take a copy. Another question is, should the component know about how to create the action? Right? Should the component know about how to create the action? Should the component know about it? Right? Need not. The component should not know about it. So what we will do, we will delegate the responsibility of creating the action to another entity. We will delegate the responsibility of creating the action to another entity. Who is that? That we call as an action creator. Okay, so I'll show you. So constant spinner action creators is equal to an object, and that will have two methods. One is up method and the other one is down method. When you call the methods, what they will do, they will create the respective action and return it. Okay, so this will create the up action and it will return the action. So I'll call this as just the action. So it will create the action and return the action. And similarly, this will create the down action. This will call create the down action and return that particular action. Okay, very good. But then, how will the component have access to the action creators? We will explicitly pass it. So here, when we are entering the component, we will pass it to the component. So action creators is equal to spinner action creators. Action creators equal to spinner action creators. So here, what this will do, what the component will do, the component will get the respective action. So we'll say constant action is equal to this dot props dot action creators dot down. That will return the down action and we dispatch it. So constant action is equal to this dot props dot action creators dot up. Okay, and you get the action and you dispatch that particular action. So all we have done is introducing action creators. So introducing action creators. So the responsibility of creating an action is removed from the component. Right? The responsibility of creating the action is removed from the component. So we are introducing the action creators here. Okay, let us check if this is working. 0, 3, and now you call up, 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 down, 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 working just fine. Okay, so one more step closer to create a dumb component, right? One more step closer to create a dumb component. So introducing action creators. So copy this. Let me check this in. Code is checked in. Are we good?
Yep, good.
Okay, very good. Now, now, when you look at these two methods, when you look at these two methods, what are they doing? They are doing ditto the same thing, right? They call the action creator, get, get the action object, and dispatch. This also calls the action creator, gets the action object, and dispatch. Are they doing anything specific, anything unique? No, they are not doing anything unique. All they do is every time you click the button, they call the respective action creator, get the action object, and dispatch. That is what they are doing. They are not doing anything unique. So, should that be done by the component? Right? Should that be done by the component? You don't have to. So what we will do, we will delegate the responsibility of dispatching the action to another entity. We will delegate the responsibility of dispatching the action to another entity. So who is that? That is action dispatcher. Okay. So function bind spinner action creators. Okay, so this is bind spinner action creators. What this will take action creators and the reference to dispatch. This will take reference to the dispatch. Okay. Now this will create an action dispatcher. So constant action dispatchers is equal to an object, and that object will have the same method signature as that of action creators, will have the same method signature, same methods as that of action creators. So if action creators has up method, this will also have the up method. If action creators have down method, this will also have the down method. But when you call these methods, right, what they will do, they will not create the action. Instead, they will call the respective method of the action creator. So action creators dot up, right? And then don't return it. Your job is to dispatch it. Your job is to dispatch it. So it will simply dispatch that particular action. Now, similarly, let's come here. So this is action is equal to action creators up, down, right? So that will return the actual action object. You don't return it. your job is to dispatch it. Your job is to dispatch it, right? Now we need to create the action dispatchers. So this is a function. So this is a function that will create the action dispatchers and return the action dispatchers. So we need to create it. So it's a constant action dispatchers is equal to what is it? Bind spinner action creators with spinner action creators, comma store dot dispatch, right? So that will give you the action dispatchers. So here, what I have to do, I don't have to pass the action creators. I only have to pass the action dispatchers. So I'll say action dispatchers is equal to the action dispatchers. I am passing this. So I wrote the logic in the same file. Ah, okay. So save this as 04 index.html. And what are we doing? We are introducing spinner action dispatchers. We are introducing spinner action dispatchers. So, comment this. Okay, so now we are passing the action dispatchers. We are not passing the action creators. We are passing the action dispatchers. So in the component, we will have to, what do we have to do? We don't have to call this particular action. We don't have to call this action. We simply need to call the given method. So this will be action dispatchers dot down. That's all, right? You don't need to know how to dispatch it because the action dispatchers will take the responsibility of dispatching the action. So similarly, this will be what? Action dispatchers dot up, and you don't have to dispatch it. That will be automatically taken care by the action dispatchers. Is that clear? Right? So if I have to explain this, right? So we have the component. Here is our store, and from the component actions need to be dispatched, right? So we have created an action creator. So this is the action creator. Now we are introducing one more object called action dispatcher. Action dispatcher. So what we are doing, you simply call the action dispatcher and say, hey boss, do something, right? So in our case, it is the up method or down method. And what this will do, this will call the action creator, get the action object, and dispatch the action object. Okay, it will call the action creator, get the action object, and dispatch the action object. Earlier, this job was done by the component. Now we are delegating the responsibility of dispatching the action to the another object called action dispatcher. Okay, so the logic for creating the action dispatcher is here. So this will take the action creator and access to dispatch, and it will return the same method names. Okay, it will return an object with the methods that are the same as the action creators. So use the component simply calls the given methods, and it will simply dispatch the action. Okay, so here we are introducing the action dispatchers. Take this, have a look at it, and let me know. Code is checked in. Right? So step by step, we are making the component dumb. We are taking smaller steps with the goal of making our component dumb. Okay. Now, instead of sending the whole action dispatcher as an object, I can send only the methods. Okay. So instead of passing the whole action dispatcher as an object, I can pass only the methods. So I'll save this as 05 index.html and simplifying access to action dispatcher methods. So simplifying access to action dispatcher methods. So what do we mean by simplifying access to action dispatcher methods? So instead of passing this as a whole object, right, I will pass the individual methods. So I'll say up is equal to action dispatchers dot up and down is equal to action dispatchers dot down, right? Now, anyway, these are going to dispatch the action. We don't have to pass the reference of dispatch. The component need not know about reference to dispatch. So we are passing the reference to the up, we are passing the reference to the down from the action dispatchers. So in the component, when the button is clicked, they will simply call props dot down, props dot up. That's all, nothing else. They are not going to do anything. They will simply call props dot up and props dot down. Let us check if this is working. So 05 index.html and up, down, working just fine. Right? So instead of passing the whole object, we are passing individual methods. Okay. Now, how do I simplify this? So this you can further simplify. How I can say, instead of passing manually one at a time, this can be simplified as action dispatchers, right? Action dispatchers. So automatically all the methods of the action dispatchers will go in as props to the component. Now let's go here, reload it, up, down, works just fine. Make sense? So we simplified access to action dispatcher methods. So let's go to the let's pick it up, paste it, save it, done. Are we good? Okay. Now, if you look at here, right, what do we have in the event handlers? In the event handlers, all we have is just the up method and we call the given methods. That's all, right? We call the given functions, not even methods. For the component, it is just a function. So it is simply calling the given function. When the up button is clicked, it is calling the given function. When the down button is clicked, it is calling the given function, right? So because it is doing only these two, I can simplify writing this. How? I can receive the up and down also from the props and directly call up and down. So this is down, give the reference of down, and here give the reference of up. So save this as 06 index.html and give the reference of up. So I don't need this event handler methods. I don't need this event handler methods. I get the up and down in a variable from the props and simply call that particular function, given function. So this is 06 index.html. And now when you click up, down, it is working perfectly fine, right? So when you look at the class now, all the class is having is what? A render function. All the class has is only the render function. So what I can do, I can convert it into a functional component. So I'll paste this and we will say this is constant spinner is equal to a function, and we know that this comes as the props. So I'm going to take this out, and this is our props. And because it has only one return statement, I don't even need a floor brackets. Just return this. I don't have the need of floor brackets, and simply return this. Now, spinner as a functional component. Okay, so let me save this. This is 06 index.html, reloaded, and up, down, works just fine. Okay, so because see the class version is right here, so you can always compare. So in the case of the class version, we receive the up and down method from the props, and we are simply calling them. And because we are not managing any state, and all we are doing is we receive the data and display, and we receive the function and call the given function when the user interacts with it, right? When the user interacts with it. So our component has become a truly dumb component. It is presenting the given data and calling the given function. Beyond that, it is not doing anything else. It doesn't know what the given functions do. It doesn't know what, whether the given function is an action dispatcher function or an action creator function. It doesn't have any knowledge about any of that. All it knows is that it has to call the given functions on certain circumstances, under certain circumstances, and it is simply calling those given functions. Okay, so we'll write this as spinner as a functional component. So let me copy this, click in this. Right, the code is checked in. Shall we move on? Okay. Now, now, uh, the logic for creating the action dispatcher is too specific here. The logic for creating the action dispatcher is too specific here. What do you mean by too specific here? Uh, Now, look at this. What is this method doing? It calls the action creator method with the same name. It calls the action creator method with the same name and it dispatches that action. Similarly, the down method also, it calls the action creator method with the same name and it dispatches that particular action. Is there anything unique happening between these two methods? Is there any decision making happening? Nothing. Right? It is just the same thing being done again and again and again. So call the action creator method with the same name as the action dispatcher method and dispatch that particular action. Get the action object and dispatch that. Right? So same thing is happening again and again and again. Now, because the same logic is repeating again and again and again, right? This might lead to some minor maintenance issues. What maintenance issue? Suppose, let's say we introduce an action called double up, double up. Okay, so input type equal to button, and value equal to double up. Okay, on click equal to double up. And what is this? This is double up is an action. So let us write this. So comma and double up is an action creator. Constant action equal to type is double underscore up. And then we will return this particular action. We will return this particular action. And then in the reducer, we will write the logic for double up. So here I will say if action dot type is equal to double underscore up, right? Return current state multiplied by 2, right? Current state multiplied by 2. Okay, very good. So let me say this as 0.7. What is it? Okay, so let me say this as 0.7 index.html, and this is where I want to make these changes. So I introduced a new action type called double up and updated the reducer accordingly, and then the action creator creates the action. And let us update the view. So in the view, we already have a button, and when the button is clicked, we dispatch this particular action. Now save this. open it in the browser. So 07 07 index.html, open it in the browser, and it says that double up is not defined. Double up is not defined. Okay, so we receive it. So we'll say double up from the props and go here, reload it. Now, uh, when I click the button, nothing is happening. Up, double up, nothing is happening. Why nothing is happening? Because you know what we did? We created the action creator, but we forgot to create the action dispatcher. What the component receives? The component receives an action dispatcher. The component doesn't receive an action creator. The component only receives an action dispatcher, right? So a corresponding method need to be there in the action dispatchers. The corresponding method need to be there in the action dispatchers. So every time you add an action creator, you need to remember to to create a corresponding action dispatcher. We need to remember to create a corresponding action dispatcher. So action equal to what? Action creators dot double up, right? Get the action object and then don't return it, dispatch it. Don't return it, dispatch it. Now say this, go to the browser. This is 07 index.html, reload it. Now up. Now you click double up, it is multiplying itself perfectly fine. Is that clear? So every time you create an action creator, you also need to create the corresponding action dispatcher. You also need to create a corresponding action dispatcher. If you forget doing it, then your application will break. But if you look at the action dispatcher, it doesn't do anything unique, right? It has the methods mimicking the action creator, and then when you call those methods, all it is doing is call the corresponding action creator method, get the action object and dispatch. So do we have to do this manually? Do we have to create this manually? You don't have to create this manually. What I can do, I can dynamically create this object, right? So how I can dynamically create this object? Let me write this. So function bind action creators, that takes the action creators and reference to dispatch. And what this will do, this will say constant action dispatchers is equal to an empty object, and then iterate through each of the methods of the action creator. So for let key in action creators, and then we will simply say action dispatchers of key is equal to a function, and this will take all the arguments. And what this will do, this will call the action creators respective method, action creators of key with all the arguments, and get the action and then dispatch that particular action, and this will return the action dispatches. Okay, so this is more of a generic version of what we created here. So when we create the action dispatchers, we don't call bind spinner action dispatchers. We simply call bind action creators, right? We simply call bind action creators, pass the spinner action creators, and store our dispatch. So this is more of a generic version. Now save this, go to the browser, reload it, up, down, working just fine. Double up is also working just fine. So the advantage of generalizing creation, the generalizing the logic for creating the action dispatcher is, if you introduce a new action creator, you don't have to remember about adding it to the action dispatcher, because the action dispatcher is automatically created. For example, watch this. Here, let's have a double down, right? Double down and create a similar action. We will say this is double down, and then here in the reducer, we simply need to write the logic for it. So I will copy this, paste it, and say this is double space down, and you will get a function called double down, right? So we receive the double down also. This is the double down, and we simply call this. So all I did was I created an action creator method, and from the UI I am calling the given method, and then in the reducer I simply need to write the logic for I simply need to write the logic for double down. So double underscore down, return current state divided by 2. That's all, right? I don't have to update the action, this create dispatcher. All I need to do is I have generalized the logic for creating the action dispatcher. So generalization the logic for creating the action dispatcher. Dispatcher. So now let's go to the browser, reload it. Now you have up button, down button, double up everything. So up. Now double up is also working just fine. Down, and double down is also working just fine. So I don't have to remember, right, to add the action dispatcher because it is automatically created. I am not creating it manually one at a time. It is automatically created given the action creator as the input, right? So I have generalized the creation of action dispatchers in a function called bind action creators. Okay, so I'm checking in the code. Let's have a look at it and let me know if you have any questions. Code is checked in. Are we good?
Yep.
Okay. Right. Now, um, so in this particular example, right, till now, okay, so even before that, if you look at here, has this got anything to do with Spinner? Look at the implementation of bind action creators. Look at the implementation of bind action creators. So has this got anything to do with Spinner? No. This can be used with any application for any actions, right? You can create any action dispatcher for any application for any problem using this function because it is a very, very generic function. So this doesn't need to be in the index.html. I am going to move this into the state manager.js. Okay, so it refactor the bind action creators to be a part of state manager, right? To be a part of the state manager.js. So I'm going to take the logic for creating the action creators. So cut this and then put it in the state manager and it has another function. And we want this to be accessible from outside. So from the top level object that you are exporting, right, which is the object with create store API, we will also export the bind action creators, right? We will also export the bind action creators. So in our index.html page, I will simply say there is no local function called bind action creators. So I will call state manager dot bind action creators, spinner action creators, and store.dispatch, and it will automatically dispatch. So let me get rid of this and get rid of this, right? So all these things are gone. We don't need them. Here is a component. So this, let this be here, and the rest we don't need it. So I'll get rid of this also. Okay, so we refactored the bind action creators because it is not specific to Spinner. It is now very generic, so you can use it for any domain, right? Any action creator object. So I am moving it into the state manager, and from the state manager we can use it. Okay, all right. So I'll copy this, check in this. Okay, so there is no new logic implementation here. All we did was move the function from one file to another file. That's all. Okay, very good. Now, now, if you look at this logic, this implementation, we are not taking any inputs from the user. We are not taking any inputs from the user, right? All we are doing is we are just we have some methods and we call the given function. Every time the button is clicked, we call the given function, right? That is what all we are doing. What if we want to take some inputs? What if we want to take some inputs? How will we handle it, right? So let us take a different scenario. What is it? Till now, the increment and decrement happened by one, a fixed value of one. Increment and decrement happened by a fixed value of 1. But I don't want the increment and decrement to happen by 1. I want it to happen by a value that I want to pass as input, right? The increment should happen by a value that I pass as input. The decrement should happen by a value that I pass as input. Okay, so how do I do that? So first let us prepare the UI. I'll call this as delta. As a matter of fact, I am going to use the class. I'm going to use the class spinner class. Okay, I'm going to use a spinner class, and we will have the double down, and we will have the double up, and then we will receive the methods from the props. So double down and double up. Okay. So just make sure that this is working. So this is 09 text.html and good, right? Just make sure that this is working, and then we will make the necessary changes. 09 index.html, up, down, double up, double down, working just fine. Okay, very good. Now, I want to take some values, right? I want to take some values for input for up and down. Okay. So how do I do that? Let's say you have a div, and inside the div you have a label that says delta, right? Delta, and then we will have a text box. So type equal to number. We'll have a type equal to number. Now, if I render this, you have a delta, right? As a matter of fact, we will move this down here. Okay, so we change the UI drastically. So we have a delta, and the up operation should happen by the delta. The down should happen by the delta. So if I say 3 and click up, it should not display 1. It should display 3. If I click up again, it should not display 2. It should display 6. Right? So the increment action, increment operation should happen by the value that you enter into the text box. Similarly, the decrement operation should happen by the value that you enter into the text box. Double up, double down will be just the same. Okay, so double up, double down will be the same behavior what we already had, but only the up and down behaviors should be based on the data that we enter in the text box. Okay, very good. So how will we take the data from the text box? You can use a state. So I'm going to create a state equal to delta, which is 0 by default. And then here I will say value is equal to, right? We will take it from the state. So constant delta equal to this dot state. So I will directly display it here. And then on change is equal to, when given the event object, this dot set state of what? Delta is event dot target dot value as number. Right? So every time the text box is changing, we are keeping it in the state. Okay, that is fine. But how will I pass them? How will I pass them? So what we will do, you see here, the action creator methods, they will receive the delta as an argument. Okay, so whatever is the delta, they will receive the delta as an argument. And then how will they make this available to the reducer? Because the reducer is the one who is going to add these values. So how are you going to make these available to the reducer? We will pass this as the subsequent attribute in the action object. So in the action object, you can pass it as delta, or you can pass it as a payload, right? So however you want to pass it. The convention is usually I have seen payload, but I have also come across applications that receive this as delta. So delta is delta, and here also delta is delta, right? So I am passing the given data from the UI as a attribute of the action. And now when this is dispatched in the reducer, what we will do? So when you say up, you are not incrementing the current state by 1. Instead, you say current state plus action dot delta. And what will this be? This will be current state minus action dot delta, right? Current state minus action dot delta. That's all. Now let's go to the browser. reload this. This is 09, right? Okay, so reload this. Now you say 3 and up. Oops, stop. Target dot value as number. Action dot delta. Right. So we have to pass it. We did not pass it. So this when the method is when the button is clicked, call the down with the delta. And similarly, when this button is clicked, call the up with delta. Right? Call the up with delta. Now save this. Go to the browser. Now you call 3 and up. It is incremented by 3 and then 7 down. This is incremented by 7. Double up, and double down, working just fine the way it is supposed to work. Right? So in this example, what we have learned? We have learned how to pass inputs from the UI. When you are dispatching an action, how to pass inputs from the UI. Right? So we pass it, and the reducer picks it up from the action object and operates on it. Am I making sense?
Yep. Yep.
Right. So I'm checking in the code. Take this, have a look at it, and let me know. So this is 9 and passing the data from the UI as a part of the action object. Okay, so here is assignment for you. Convert this class into a functional component. Convert this spinner class into a functional component. Take a few minutes, finish it. Take 10 minutes. Do it quick. So if you are going to convert this into a functional component, how will you manage the state? Very good, right? Use the hook. Do it, do it. Thanks, Benny. Let me know once you're done. Guys, finish it quick.
I think we're done here.
Okay. All right. So let me also do this. So I'll save this as 10 index.html and this into a constructor function. Sorry, into a class. So comment this out. Comment this out, and this is our spinner, and use the state. So take this, copy this, paste it. And we will use, so this is so here I will get the state. So constant delta comma set delta is equal to react dot use state of 0. And then here we will display the delta, and here we will simply call set delta. That's all. Set delta of this value. That's it. So this is what all we have to do to convert it into a higher order, functional component. So this is 10 index.html, and let's say this is 2 up works just fine. Down, double down, working just fine. Okay, so I'll write this as 10 converting the spinner into a functional component. Okay, very good. Okay, good. So now we have learned how to create a reducer, how to create the action creator, and how to create an action dispatcher, and from the component how to dispatch the action, and how to pass the inputs, right? So all those things we have learned. Now, if you look at the way we have solved this problem, right? If you look at the way we have solved this problem, our solution is organized like this, right? Our solution is organized like this. What is it? Here is our component. Here is our component. Here is our reducer. Here is our reducer function. Okay. Here is our store. This is our store. And here is our render app function. Here is our render app function. And here is the action dispatcher. And here is our action creator. Right? Here is our action creator. Now, when you render the application, right? What the component receives? The component receives the data. The component receives the action dispatcher functions. It is receiving the action dispatcher methods. And now the user is interacting with the application. The user is interacting with the application. He clicks a button, he enters some data in the text box, he does something, right? And what the component does, the component calls the action dispatcher and say, boss, dispatch this. The action dispatcher gets the action object from the action creator, and it is dispatching the action to the store. What the store does, store calls the given reducer and say, hey boss, this is the action performed by the user, you handle it, right? You handle it. And the reducer operates on it, returns the new state. When it returns the new state, the store updates its current state, and then it calls the render function and say, boss, something has changed. Now you re-render. Now once again, the render will render the data, and once again it is displaying the data. Now everyone waits, and then the user interacts. The component talks to the action dispatcher, gets the action object, dispatches it. The store gives it to the reducer, gets the new state, calls the render app, and the component is rendered again with the new data, and the component displays that particular data. Now everyone waits again. The user interacts with it, the same flow, right? In the whole application, this is the same flow that happens again and again and again. This is the same flow that happens again and again and again. What you will notice is the data flows in this direction, right? The data flows in this direction. There is no reverse communication per se, right? There is absolutely no reverse communication. The data flows in only one direction. There is no reverse communication. This is what we call as the unidirectional data flow. Okay, this is what we call as unidirectional data flow. The data flows in one direction from the UI through the action dispatcher. It reaches the reducer, it reaches the store hands it over to the reducer returns new data, the store gets updated, and the component is re-rendered. Now everyone waits, the user interacts, the same flow happens again and again and again. And when your application grows more and more complex, this gives a lot of clarity about how the data is changing, when the data is changing, where the data is changing, right? So it becomes extremely easy for you to implement changes. So your application becomes more and more maintainable, right? And the store is called as a single source of truth for your application, because the store contains the whole application state. The complete state of your application is maintained in the store, so it is called as the single source of truth. So at any point of time, if you want to know what is the state of the application, you don't have to go and look into 1,000 objects. You just have to look into one object, which is the store. So that will tell you what is the current state of the application at any point of time, right? So this brings in a lot of clarity about how you manipulate data, how you manage your data, how you change your data, right? So that is why this idea took the world by storm. And even though this idea was initially adopted only for React, we started incorporating this idea in other frameworks also. For example, in Angular also we have a similar infrastructure. In Vue.js also we have a similar infrastructure. In almost all major UI frameworks we have a similar infrastructure available. Is that clear? Okay, now here is the most interesting part. What is it? We don't have to create the state manager. So whatever logic that we wrote, we don't have to create this. We created this for the sake of learning, right? But we don't have to create this. Why? This infrastructure is available as a third-party library called what? Redux. Okay, this infrastructure is available as a third-party library called Redux. So if you go to redux.js.org, that's the website. So go to redux.js.org. If you go to redux.js.org, and it is a state manager, it is a state container. Okay, and go to the APIs. So I'm in the API, and look at the top level APIs here, top level exports. The top level exports has a create store, right? And what is the argument it takes? It takes a reducer. And then fourth one, bind action creators. What does it take? It takes an action creator and dispatch. And then what is the store API? What are the methods of the store API of the store? So the store API, what all it has? It has get state, it has dispatch of action, and then it has a subscribe, takes a listener, and we call it as a callback. This is the variable name is listener. So more or less we implemented whatever the Redux does, right? Albeit for a very simple problem, right? Our implementation is not perfect. I would not suggest, I will not use our implementation in a production application because we have not taken into consideration exception handling. We have not taken into consideration async actions, extensibility using middlewares, and preloading the state, replacing the reducer at runtime. Right? So we have not considered all those things. So ours is a very basic implementation with the goal, with the aim of learning what's happening inside this library, right? That's all. We are supposed to discuss Redux. So instead of using the Redux library and explaining the APIs, we created a Redux-like library from the scratch so that we can easily understand what happens behind the scene in the Redux library. Now, how close is the library with our implementation, with our problem, right? Can we replace the state manager, our state manager.js with redux.js, and can we expect the spinner to work still? Yes, with respect to our problem, our implementation matches what Redux offers. Okay, so I'll show you. So first of all, let us download this. So go to get started, and you can install it as a node module. All this we will do tomorrow. And here you see the EMD package can be used as a script tag directly. So click the link. This is the library. This is the implementation of Redux. Okay, this is the implementation of Redux. So you see bind action creators. So bind action creators, taking the action creators and dispatch, and then we bound action creators equal to an object for each key in action creator, right? So they are doing more or less the same thing that we did. Okay, and then now I am going to use this library. So save this file in the folder. So in the state manager folder, save the redux.js, and then let me save the 10 index.html as 11 index.html and replace state manager .js with redux.js. Replace state manager.js with redux.js. So in the script tag, replace the state manager with redux.js. Okay, done. Now, our state manager exposes all its functionality through a top-level object called state manager. Redux exposes all its functionality through a top-level object called Redux. Okay, so Redux here, redux.createStore, and then there is one more place where we are using Redux, bind action creators, right? State manager bind action creators. So I will simply replace the state manager reference with Redux with a capital R. Now save this, go to the browser and load number 11 index.html, and I'll say this is we up works just fine, and 7 down works just fine. Double down, this working perfectly fine, right? So with respect to our problem, right, whatever we are doing with the spinner with respect to our problem, the implementation closely matches what Redux has. Okay, good. So I'm checking in this code. Take this, have a look at it. So replacing state manager .js with redux dot. Make sense? Guys, are we good? Yep. All right. I think it is time for a tea break. 15 minutes.
Yeah. Thank you.
So has this discussion helped in understanding Redux? Because most of you in your survey, your concern was primarily on Redux.
He's asking what it is. Yes, I think, yeah, it was
it is
helpful.
really helpful.
Thank you.
Brick.
Was it?
Yeah.
Was really?
Yeah.
How long have you got? How long have you got?
I think
10 minutes?
15.
15.
Yeah, I think it's 5 minutes already gone.
Okay.
Yeah, the moment it's been. As you went out, if Phil, yeah, we need to.
Go ahead.
We are supposed to be on mute.
All right, everyone in? Roll call. Good. Okay. Now, let us take a slightly complex problem and solve it, and that will give us enough scope for better understanding of how to solve problems using this infrastructure. Okay, so whatever we are discussing now. Uh, um, what we will do, we'll build a simple bug tracker application, and some of the use cases that we will build are, I'll write it down. So let me create a new folder, 04 bug tracker, and create a new file, um, index.html. So html:5. So this is bug tracker, and split type equal to /use cases. Let us define the use cases. The user should be, so as the name implies, this is a very basic application for managing bugs, software bugs. Okay, and what are the expected behavior? So these are all the expected behavior. The user should be able to add new bugs. The user should be able to toggle the closed status of any bug, and the user should be able to remove any bug, and the user should be able to remove closed bugs, and then we will display list the bugs. Sorry, this list the bugs, and toggle the closed status, remove any bug, remove closed bugs. And number 6, we will display the stats, more or less, right? The example that we did with products, more or less the same thing. So display the stats. So this is number of closed bugs by total number of bugs. Total number of bugs. And then we want to sort the bugs and persist the bugs in the server and make the bugs accessible using unique URLs. Make the bug accessible using unique URLs, and bundle and deploy the app. Bundle and deploy the app. Okay, so these are all the use cases, and we are going to implement all these use cases in a simple application. And we will, as I said, we will implement this in an index.html page itself. And tomorrow we will convert it into a proper application, and there we will discuss about how we can use TypeScript instead of JavaScript. How we can use TypeScript to implement this. Okay. All right. So what will be the UI? The UI will be something like this. So bug tracker and HR section.stats and closed one span of this and of two, and then section.sort label added by, and select containing multiple options. Then a label something and colon checkbox. Section label name equal to and TLS span bug name dollar is return to have a button and wait and colon closed. So here is our UI, and let me define some basic style, so it will be easy. Size. As a matter of fact, we also have the section. So one of the bugs will mark as. Alright, so we have the UI created. Let me load this. There you go. Right? So there's a very basic UI, nothing very complicated, very simple UI. And if you look at the use cases, we can very easily relate what we are trying to do. So I should be able to add new bugs. So type something and click add new. I should be able to add it. And then list the bugs. So we list the bugs here, and then toggle the close status of any bug. So here is our bug name, and you see it is clickable. So you click this, it becomes open. You click it again, it becomes closed. If it is open, it will be closed. If it is closed, it will be open. And we display the date and time at which the bug was created. And if you click this button, automatically the bug has to be removed. And if you click remove closed, all the closed bugs have to be removed. And here we will display some options. So when the user selects those options, automatically the bugs have to be sorted, maybe by name, by status, by created at, right? By any of those things. And then here you have the descending option. So if you click the checkbox, then the bugs have to be sorted in descending order. And while we manipulate all these bugs, adding the bugs, toggling the bugs, removing the bugs, etc., automatically what should happen? The stats has to be updated, kept updated at all times. This should always reflect the current status of the bugs at all times. Okay, so this is the UI, and we are going to solve this problem using our state manager, right? We are going to solve this problem using state manager. So for some time, I will use a state manager, and then I will get rid of the state manager and I will use Redux. There is another very important thing that we need to know, and we will learn it when we use the state manager, and then I will throw away the state manager and replace it with Redux. Okay, all right. So I'm checking in the code in case if you are interested, you can take it and follow. So let me add the files. How many files? So this is react.development.js and react-down.development.js and babel.min.js and then state manager.js. Okay, and then script type equal to text/babel, type equal to text/babel, and then okay, so here is the thing. So this is another important thing that I wanted to discuss for a long time. Let's say I'm creating a component. Okay, so I'm going to take this and make it into a component. So first replace all the class references with class name and all for references with HTML for, and just make sure that all input tags have the close tag, right? And that's pretty much it. So I take this, create a component. So we'll say class bug tracker and extends react.component and the return paste. Right? Now, I cannot return this. I cannot return this. I have to return all these things. All these things need to be wrapped in one more element, and that element has to be returned, a React element, and that element has to be returned, right? So that is what we learned. But the problem is, when you receive the HTML, let's say you are using a web designer, you are getting the help of a web designer, and the web designer is giving you this, okay, this HTML. The web designer is giving you this HTML, and he has created the CSS classes, CSS style rules based on this hierarchy. What hierarchy? You have the section directly under the body, right? He has defined the CSS rules in such a way that he has applied the styles for the sections that are directly below the body, children of body. But when you try to convert this into a React component, right? So what happens? You cannot return it as it is. You cannot return it as it is. So what you have to do? You have to introduce a div, right? You have to introduce a div, and now you are introducing one more level of HTML tags that can break the CSS rules, right? You are introducing one more level of HTML tags that can introduce this, that can break the CSS rules. So this is a problem that existed for a very long time, and what they have done in React 16 is they have introduced a way by which you can satisfy the expectations of React without breaking the HTML hierarchy, right? What is it? It is called React.fragment. Okay, so you wrap your elements inside React.fragment, and that will not introduce a new hierarchy in your HTML, right? That will not introduce a new hierarchy in your HTML. Okay, very good. Now let me add the root node and we will render this. So we'll say React DOM dot render the bug tracker document dot get element by ID of roots. Okay, documented determined by ID of root. Okay, very good. Now let me load this, and to do that I need the script files. So state manager, Babel, DOM, Redux, state manager. So I'm copying all the script files, and then let me add them here. Okay, now let us load the page in the browser. So reload it. Everything is rendered, but they are rendered through React. It's not rendered as normal HTML. These are rendered as the React components. Right? These are rendered as a React component. Okay, very good. Now let us write the logic. Right? Let us write the logic. So how do we write the logic? For each of the use cases, we have to implement. Guys, are you following? Are you there? You are all there? Okay, good. All right, so let me check in this, and if you want, you can take it. So bug tracker initial. Okay, so I've checked in. Now, let us take the first use case. The user should be able to add new bugs. The user should be able to add new bugs. So where will he add it? Obviously, what are the things we need? We need a reducer, we need an action creator, and we will have to dynamically create an action dispatcher. And in order to create the action dispatcher, you need to have a store, right? So let us take one step at a time. First of all, we need a reducer, right? So we'll say function bugs reducer current state. So what will be the current state? Default current state, right? Here I'm going to take an array as the default current state and an action. Okay. Now I'm going to check. See, the action types, you can create a string, constant strings, and you can use them for checking if the actions are, instead of hard coding the action strings, you can define them as a variable, as a constant, and then use them, right? So all those things we can do. But for now, our focus is on Redux. So I'm going to check if, first make sure that you return the current state. Don't forget, right? First write that line. Whenever you are creating a reducer, first write that line. To initialize the store with the default state, the valid state. And then if action dot type is equal to add new bug. If action dot type equal to add new bug, what am I supposed to do? Right? Now I have to create a new bug object. Where will I create the bug object? Where will I create the bug object? So constant bug action creators is equal to an object where we will have an add new method that takes the new bug name, right? So I have to create a new bug object in one of these two places. Where will I do that? Remember, in the case of the spinner example, right, the business logic is not very complicated. It is simply adding a number, subtracting a number, etc. So we took the liberty of doing the main business logic in the reducer, right? But when you are building complex applications, the business logic should not be in the reducer. The business logic should be in the action creators, right? It is extremely important. All your business logic should be in the action creators. And what the reducers should have? The reducers should have the logic for synchronizing the state changes in the store. That's all. That is what all the reducers have to do. The reducer should not have any core business logic. Okay. So this is where I have to create a new bug object. So constant new bug is equal to an object where name is new bug name, comma, is closed is false, comma, created at is new date, right? Created at is new date. And I want to have a unique ID also. So I will give the ID as 0, or at this point of time, because we are managing all the bugs in the memory in the browser itself, right? I'm going to have a hack. I am going to use a hack here, and we will get rid of this hack when we talk about server communication a bit later. So here, let us say let current bug ID equal to 0, and every time a new bug is created, I am going to add it plus current bug ID, right? So as I said earlier, this is only a hack, and we will get rid of this in a while. And then let us create the action. So constant action is equal to an object where type is add underscore new underscore bug, comma, payload, right? Payload is what? The new bug, right? So the payload is basically a convention that we use to communicate the supporting data to perform that particular action. So there are applications that use this convention. There are applications that doesn't use this convention. They simply send it as new bug. Okay. So however you want to use it, you can use it. So you can also say new bug colon new bug, and then we will return this action. We will return this action. Okay, very good. Now what the reducer will do on receiving it? So it will say constant new bug is equal to action dot payload, and what we will do? We will say current state dot push the new bug, and we will return the current state. We will return the current state. Very good. So this is done. What is the next step? Next step is creating the store, right? Creating the store. So let us create the store here. Constant store is equal to state manager dot create store for what? The bugs reducer. And then we need to create the action dispatchers. So constant bug action dispatchers is equal to state manager dot bind action creators with the bug action creators, comma store dot dispatch, store dot dispatch, and then we will wrap this inside a function in the wrap and call the render app, and then we will say store dot subscribe of the render app. Store.subscribe of the render app. And here we take the data and pass it. So we'll say constant bugs equal to store.getState. Constant bugs equal to store.getState, and we will pass the bugs as the props. And then we will also pass the bug action dispatchers. We will also pass the bug action dispatchers. So when we pass this in the component, what we will do, we will have the state variable. So state equal to new bug name is an empty string. And then in the text box, we will have it. So value equal to new bug name, and then comma on click, on change is equal to, and given the event object, say this dot set state of new bug name is event dot target dot value. Like nothing new. We are doing the same thing. And when the button is clicked, right, we will call the add new, the given add new with the new bug name. So whereas add a new bug name, we will write it. So constant new bug name, take it from the state. Take it from the state, and then add new will be given as props. So equal to this dot props. And when the button is clicked, we simply call the add new with the new bug name. Now, to know whether it is working or not, I am going to simply update the total number of bugs, right? This particular span where we are displaying the total number of bugs. So this, I will replace it with bugs.len. Bugs.len. And where is the bugs? The bugs will also come as props. Right? The bugs will also be received as props. Now save this, go to the browser, reload it. Now it is displaying 0. Ignore this part, right? We have not written the logic to list the bugs. Ignore this part. So this is 0. And now let us enter some data in the text box. And let's say server communication failure. And I'm clicking the button. There is an error. What is the error? Cannot read property new bug of undefined bugs reducer action dot new bug. Sorry. Action, right? We are not using the action dot payload. We are using the action as it is. So from the action, we take the new bug. So reload this and say server communication failure and click add new. I have clicked it, but this is not reflecting that. The count is not reflecting. Now, is the data in the store? Let us figure it out. So store.getState. I will call store.getState. Yes, right? So what you entered here in the text box has reached the store, but it is not displaying the UI. Can you tell me why it is not displaying in the UI? I am checking in this code. Take this code and tell me why it is not displayed in the UI. Code is checked in. Take it and tell me why it is not displayed in the UI, why it is not reflecting in the UI. Why? Why?
Sorry, if you're looking for an answer, I mean, there's nothing that adds the bug to the list. So
We have added. It gets added, so it is reflecting in the store.
oh yeah, maybe I was looking at the wrong thing then. So sorry, did you want the count or did you want the actual display of the bug?
Count. Even the count has.
Okay.
That's all. See, the beauty of this model is, as I told you, it is very easy, not allowed to do it via push, right? But why is that a problem? Why is that a problem? Okay, so that is what we are going to discuss. So as I said earlier, the beauty of this model of managing this way of managing state in your application is that it gives you a very clear-cut idea about what happens in your application, what happens to the data in your application. So let me redraw this. So here is our store. Here is our store. Here is the UI. Here is the reducer, right? And using the action dispatcher. So when the user interacts with the application, the action is dispatched. It reaches the store calls the reducer returns the data, and then you call the render app function, and the render app re-renders the application, right? The render app re-renders the application. So this is the flow that is typically followed. And now, if something is not displayed, if something is not displayed in the UI, right? We need to figure out if the data has reached the store or not. And if the data is updated in the store but not displayed here, then the problem is the communication in this direction. But if the data itself is not updated in the store, then we need to look at the action dispatchers and the reducer, right? So we have very clear-cut areas where we have to look at in order to know what's happening in the application. And if something is not happening right, then we can figure it out. So if you look at here, right, when you add a new bug, right, the data seem to have reached the reducer. The action is being created and given to the store. The action is created and given to the store. The store spoke to the reducer and the reducer has returned it. How do I say so? Because the data is updated in the store. The data is updated in the store. So what's not happening? The re-rendering of the component is not happening. So this communication, that the state has changed in the store, the state has changed in the store, right? This communication is not received. Why? Under what circumstances the store will call the subscriber and say, hey boss, state is changed? Under what circumstances the store will do that? Only when the store recognizes that the state is changed. Only when the store recognizes that the state is changed, right? Now, on what basis the store recognizes that the state is changed? On what basis the store recognizes that the state is changed? If you look at our state manager implementation, when do we decide whether the state is changed or not? How does the store decide whether the state is changed? All it does is it calls the reducer, gets what the reducer returns in a variable, and then it compares that variable with the current state that it already has. And if they are different, then it assumes that the state is changed and it calls the client and say, boss, things have changed. If they are the same, then nothing is happening. It simply returns. So the mechanism that the state manager follows to check whether the given state is changed or not is simply comparing them directly, right? Simply comparing them directly. If it is a number, right? Then you will compare them by value. If it is a string, you will compare them by value. If it is a boolean, you will compare them by value. But if it is an array or an object or a function, then how is the comparison happens? The comparison happens by reference. So the state manager doesn't look into the array to see if the state is changed or not. It doesn't look into the array to see if a new bug is added, if an existing bug is removed. It doesn't look into the array. It simply compares, hey, I gave you one array earlier, now you are returning me something, are they the same? If they are same, right? So how is that compared? It is compared by reference. So in our reducer, what are we doing? We are updating the current array and returning the array. Right? Because we are updating the same array and returning the array, the state manager doesn't recognize that as a state change because the array remained the same. So this will be true. This will become true. So it doesn't recognize that as a state change, right? So what do you have to do if you want the state manager to recognize that as a state change? You have to create a new array and return, right? Immutability. So the fundamental state management strategy in Redux is immutability. The reducer should always return new state, which means what? New object. So the state should not be treated as mutable and you can change the state. You should not do that. You should always treat the state as immutable. And if you want to change it, you have to return a new object. Okay. So guys, are you following?
Yep.
Okay. Okay. So the way you can force yourself to do that is, what I typically do is every time I create a reducer in the action method, action function where I am checking the action, first and foremost thing that I write is create a new state variable. Okay, and then return the new state, and then decide how to create that particular new state. So our new state will be a new array with all the data from the current state and the new bug, right? With all the data from the current state and the new bug. Now save this, go to the browser, reload it. Now you add a bug. So bug 1, add new. Now this is incrementing. So 1 is happening, 2 is happening, 3 is happening, everything is working just fine, right? Click it, click it, click it. It is working just fine. So now the whole cycle is working, right? So from here to here, the whole cycle is working perfectly fine. Make sense? So the very important takeaway from this discussion is your state should be treated as immutable, and from the reducer, you should not return. If you are changing the current state, you should not modify the current state and return it. You should create a new object, new state, and then return it from there. Okay, so that is what you are expected to do. Okay, very good. Now let us look at the next use case. Listing the bugs. Listing the bugs is easy, not very complicated. So we will take this and then create bug items is equal to bugs dot map. Bugs dot map. Take one bug at a time and return this. Return this, and to this we can give the bug ID as the key because it is not going to change. We will give the bug ID as the key, and this is going to be what? This is bug dot name, and this is bug dot created at. If you want to change it, you can always change it. So bug dot created at. Okay, delete, we will leave it as such for now, and then this will be replaced with the bug items. This will be replaced with the bug items. Now go back, reload, nothing is displayed, and you say server communication failure. Add objects are not valid. Oh, okay. Because we are displaying the date, right? The bug dot created it is an object, so it is throwing an error. So you can say dot to string. What you display here must be strings. So display that. Good. So now say server communication failure, add new. It is displaying it, and then you can say user actions not recognized. Okay, so it is displayed here. So the count is reflecting the number of bugs perfectly fine. Very good. Now let us do the toggle part. Okay, so I want to toggle the bug, toggle the current status of the bug. So what all we have completed? Add new is done, and listing is also done. Listing is also done. Now let us do the toggle. So what will I do for toggle? Let us write an action for that. So comma toggle is a bug to toggle. Toggle is a bug to toggle. And remember, any state change must happen in an immutable fashion. Right? Any state change must happen in an immutable fashion. So what I will do, I will create a new bug. So constant toggled bug is equal to an object with all the attributes of bug to toggle, comma, the is closed is not of bug to toggle dot is closed. And then I want to create an action. So constant action equal to an object. I want to replace this bug, right? In the store state, the old bug need to be replaced with this particular bug. So we'll say type, I can create it as replace underscore bug, and then comma, what is it? The bug is bug to replace is the toggled bug, and then return this particular action. Return this particular action, bug to replace, right? So here, let us write this: if action dot type is equal to replace underscore bug, then constant bug to replace is equal to action. Take it from the action, and then constant new state is equal to current state dot map. Take one bug at a time and check if the ID is equivalent to the bug to replace dot ID. Then take the bug to replace, otherwise retain the original bug as it is, and then return the new state. And in our view, right, so we will receive the toggle as the props. And when the bug is clicked, all I'm going to do is call the, so on click is equal to, when given, we will call toggle of that particular bug. We'll call the toggle of that particular bug. And for now, I am going to display the bug dot is closed dot toString slash div, just to know if it is working. Okay, go back, reload, and we'll say bug1 add new, bug2 add new, bug3 add new. Now click the first one, it shows it is true. Click the second one, it shows it is true. Click it, it is false. Click it, it is false. Right? So the whole cycle, the whole flow is completed. Okay. Now I don't want to display the true or false. I want to display the bug name in different, in different style, right? If the bug is clicked. So if the bug is toggled, right? So you can wrap this. So you can say bug dot is closed, then display this, else display this. So here I will say this is closed. This is closed. Now save this, go to the browser, reload it, and you say this is bug1 add new, bug2 add new, bug3 add new. Toggle, it is displaying bug of 1, bug3 it is also displaying. Now similarly, let us write the implementation for remove bug. So we will have a remove method that take the bug to remove, and constant action equal to a type and remove underscore bug, comma bug to remove. Just say bug to remove. Automatically that will become an attribute, and then return that particular action. So here, if action dot type is equal to bug remove bug, I'll simply say constant new state is equal to current state dot filter, take one bug at a time, and just make sure that the bug dot id is not equivalent to the bug to remove dot id. Okay, and return the new state. So what is the bug to remove? Constant bug to remove is from the action, right? From the action we will take it. And from the UI, when the button is clicked, all I am going to do is on click is equal to when given this, then what is the method name? Remove. So we call remove with the bug. So we will take the remove also from the box. We'll take the remove also from the box. Okay, let's go here, reload it. We'll say bug1 add new, bug2 add new, bug3 add new, toggle, remove one of them. It is remove. Bug2 is remove. Right now, while I am doing this, I also want to have the stats reflecting the current closed count. Okay, so how do I do that? We can write it right here itself. So closed count is equal to bugs.reduce, take the result and one bug at a time, and check if the bug is closed, then plus result, otherwise return the result as it is starting from 0, and you display the closed count here. You display the closed count here. So reload this, and now this is displaying 0 of 0, and we'll say bug1 add new, bug2 add new, I'm sorry, bug3 add new. Right now, when you toggle, this shows 1 out of 3, 2 out of 3. Right, so this is showing the stats. Okay, now I have to remove the closed bugs. So how can I remove the closed bugs? So first of all, let us write the action for that. So action created for that. So remove closed. Now here comes a bigger dilemma. What is it? Where will I write the logic for finding out the bugs to remove? Where will I write the logic for finding out the bugs to remove, right? That logic should be in the action. It should not be in the reducer. It should be in the action. Either you can write the logic for finding the bugs to remove, or you can write the logic for retaining, right? Finding out the bugs to retain. Okay, so anything is fine. I am going to write it as we are going to identify the bugs to remove, and the reducer will actually remove it from the current state. Okay, now to do that, I need to have access to the bugs, current bugs. Only when I have access to the current bugs, I can find out the bugs that need to be removed. Only when I have access to the current bugs, I can find out the bugs to remove. Do I have access to current bugs in the action creator? Do I have access to current bugs in the action creator? You don't have. Do I have access to the current state from the store? You don't have, right? So once again, we are going to introduce one more hack. What is it? We are going to pass the bugs from the UI. Right? We are going to pass the bugs from the UI. Right? This is a hack. Why? At this point of time, the button may be in a component that has access to bugs. At this point of time, the button may be in a component that has access to bugs, but it will not be always the same. I told you, right? You might want to display the data from anywhere in the application. You might want to initiate an action from anywhere in the application, right? So if the button is in a component that does not have access to the bugs, how can it call the remove closed action with the bugs? It cannot do it, right? So this is a hack. We will fix it tomorrow, right? When we use middlewares, we will fix it tomorrow. So here, what I'm going to do when the button is clicked, I'm going to call on click is equal to when do this, call remove closed. with the existing bugs. You are passing the existing bugs here, and what we will do, we will say constant bugs to remove is equal to bugs dot filter. When given a bug, make sure that it is closed, and then constant action is equal to type is remove underscore bugs, right? Not one bug, remove underscore bugs, and then bugs to remove multiple bugs, and then return this action. So in the reducer, we will say if action dot type is equal to remove underscore bugs. If action dot type equal to remove underscore bugs, right? What we will do, we will check if the bug is not there. So I am going to write constant bugs to remove is equal to the action, take it from the action, and then we will say constant new state equal to something, and make sure you return the new state. And here I will say bugs current state dot filter, take one bug at a time and make sure that it is not in the bugs to remove. So how will I check if it is not in the bugs to remove? So not bugs to remove dot find of the bug, right? Bug to remove, and the bug to remove dot id should be equivalent to the bug dot id. Okay, so I'm searching the array to find if the bug exists. If the bug exists, it will not make it into the final list. It should not exist. Right? It should not exist. Okay, very good. So we do remove bugs, and we have initiated the call. Let us reload this and say this is bug 1, add new, bug 2, add new, bug 3, add new, toggle, remove closed. There is an error. What is the error? Remove closed is not defined on onClick. Remove closed, we have to receive it from the props. We forgot to receive it from the props. So remove closed, and receiving from the props, reload it, and let's say bug 1, add new, bug 2, add new, bug 3, add new, bug 4, and toggle 1, toggle 3, this shows 2 out of 4, and click remove closed. 1 and 3 are gone, 2 and 4 are retained, and this is displaying 0 out of 2. Right? So we managed to remove the closed bugs. So we have toggled, we have removed, and we have removed the closed bugs, and we are also displaying the stats. We are also displaying the stats. Okay. Now I am checking in the code. Take this. We will do one more exercise, and then we will wind up for the day. Okay, make sure you understand what we have done, and then we will do this. So adding testing, toggling, and removing bugs with stats complete. Code is checked in. Okay. All right. So any questions? Are we good?
Yep, good.
Okay. Now, so one of the problems that we faced in the old example, right, before we started discussing about the state manager, one of the problems that we discussed was refactoring became very difficult. When you have to break it into smaller components, it accessing the data, and when the component communicates to the data, when the state is changing, it was unable to reflect in the UI, right? So those were all the problems. Basically, breaking the component into smaller components forced us to have reverse communication logic implemented, and that would create a lot of problems when the application complexity increases. Now, how is that problem solved in the state manager example, right? How easy or difficult it is to break it into smaller components. Okay, so what I will do, I will take this and break it into smaller components. So 0 through index.html, and here let us take each of them and make them into smaller components. So first and foremost, let us take this, the stats part. So I'll take the stats part and convert it into a component. So constant buck stats is equal to bucks. I know that it doesn't involve any state, so I'm going to directly create it as a functional component and return this. And the logic for calculating the closed count will go into this component. So constant, the logic for calculating the closed count goes here, and then you render this. So here I will simply say this is buck stats and bucks equal to bucks. Just pass the data that it wants, right? And the sort, we have not implemented it, so I'm going to create it as a dummy functional component. So buck sort equal to a component that in turn returns this, right? So I'm simply going to replace this with buck sort. And then the bug edit part, take it and make it as a different component. So either you can use a state, or you can use a class, hook, or you can create it as a class. For now, I'm going to create it as a class. So class bug edit extends React dot component render return this. And here I need the state. So the state will be moved here, and I need the on change, on click. So I need access to add new, right? So where will I get add new? So constant add new is equal to this dot props. I am expecting the add new function to be given as props, the action dispatcher to be given as props. So here I will say this is bug edit add new is equal to add new. And this, I want to create it into another component. Okay, so I'll create it as a functional component. So constant bug list is equal to, we get the props, and when we get the props, we want to return this. Right? We want to return this. But then, what are the things we want? What are the things we want? We want the bugs. We want the bugs. We want access to toggle. We want access to remove. We want access to remove closed. So we want all of them. And so this, I will take it and create it here. So constant bug items equal to, we do this, and then we render this, toggle, remove, and everything. But then I want to refactor this into its own component, a bug item component. You can very well do that. So we'll say constant bug item is equal to a prop that takes the bug and remove and toggle, right? So these are all the actions that we want. And what this returns? This simply returns this li. That's all, nothing else, right? So you have access to toggle, you have access to remove, and you have access to the bug. So you simply remove the return this. So you don't need the key here, but the key has to be here. So here we will say return a bug item key equal to the bug.id, and then what are the things I have to pass? I have to pass toggle, I have to pass remove, I have to pass remove closed. The bug, right? So I can pass it in one shot. So I'll say bug, comma toggle, comma remove. I'm passing all of them in one shot, and that will automatically be passed to the bug item. And the bug item will remove this and act on it and return. Now here, what we will do, I will simply say this is bug list with what? With bugs, comma toggle, comma remove closed. So all of them that goes in there. Now you don't need this. You don't need this. So all you have is what? Just a plain simple wrapper that encapsulates, that is composed of bug stats, bug sort, bug edit, bug list, and we pass only the data that is needed for the data. In some cases we pass data, in some cases we could pass action dispatches, in some cases we pass all of them. Okay, and see, it becomes a lot more easier to refactor our code into smaller components. So bigger component into smaller components. So 0 to index.html throws an error. Bug edit, new bug name is not defined in the bug edit. Okay. So we need to take it from the state. So constant new bug name is equal to this dot state. I forgot to copy that line. So reload it. Is loaded. Now you add a bug. So bug 1 add new, bug 2 add new, bug 3 add new, bug 4 add new, toggle, right? And remove one of them. It's working. And say remove closed. It is working. 0 of 1. Everything is working. So when you want to break them into smaller components, it is not going to make your life very difficult. It is actually very simple to break a bigger component into smaller component, right? Why? Because of the unidirectional data flow, right? So we don't engage in reverse communication. The breaking down into smaller components becomes a problem only when you engage in a reverse communication. Here we are not engaging in reverse communication. We simply call the given functions, and the data flows in one direction, right? So this makes it extremely easy to break your application into smaller components, which is very important if you want the application to be maintainable in the long run. Make sense? Now, can I replace the state manager with Redux? Let us figure it out. So I'll say redux.js, and then wherever we are using the state manager, we will use the word Redux. We will use the top level object Redux. So where are we using it? Here is where we are creating the store. So this will become redux.createStore, and this will become redux.bindActionCreators. Save this, go to the browser, reload it, blah blah blah, add, toggle, delete, add, toggle, and remove closed. Everything works just fine. Make sense? Good. So refactoring bug tracker component into smaller components.
With your refactoring, just with the functional components, is the rule like a hard and fast rule? If it doesn't have state, then it's a functional component as opposed to a class component?
No. That is gone. You still can convert it into, all the components can be converted into functional components using hooks. Okay, so I wrote it as a class because I didn't want to change the logic to use the hooks. I simply copied and pasted the code from the bigger component to create a smaller component. So that is why I had to do it fast. So I created a class. But this can very easily be converted into a functional component.
Okay.
All class components can be replaced with functional components today with the help of hooks. Even this can be converted into a functional component. This will work. Right? So constant buck tracker equal to, and we will simply return this. So this whole stuff here. And this will be in the box. So, right? So this doesn't manage any state. So I'm simply taking it from the props and rendering this. It will work. And if you want this to be converted into, you know how to do it, right? Use a hook to change it. That's all.
Yep. Okay. Good.
All right. Okay. So tomorrow, what we will do, we will learn how to bring in multiple reducers. So this is only one reducer. So how are we going to deal with multiple reducers? Obviously, in your application, you will have to deal with multiple reducers. So how are we going to deal with multiple reducers? We will learn about async actions. So how do we do server communication? We will learn about async actions. And in that process, we will learn about Redux Thunk and as well as Redux Saga. And then creating the application as a proper application using TypeScript. So we will port this application into a proper application using TypeScript, using the create React app, and then build and deployment, right? So that will be the agenda for tomorrow.
Okay then. Thanks very much. That's it.
Was today's session useful?
Certainly.
Very good.
All right. Thank you. We'll meet tomorrow then.
Thank you. See you tomorrow.
Right.
Thanks, Ruben.
Thank you.
When are you going to stop recording?
Yep. The one we recorded this morning, Google's still processing it for like almost 5 hours.
Recording 4K.
Benny, is there a way I can